Hi, Renaud Anjoran here. I'll be your host today, and I am with our senior engineer, Paul Adams. Hey, Paul, how are you doing?
Hi, yes, good to be back, and hello, sir.
So, today we are talking about the experience effect and basically why costs go down over time in mass production, but also when that happens and when it doesn't really happen, and when it's more likely to happen, right? But costs do go down over a long series of production of the same product. This is rather intuitive, rather obvious, but let's explore this topic. This okay. So first, an example, sort of the historical perspective here. Boeing in the 40s and 50s were making already a bunch of airplanes, including some for the military in the US, right? And a lot of data were recorded about some of the airplane production runs, and specifically for the B-17. So it's a big bomber, right? Started production in 1941, and they actually kept track of how many people were working on it. They estimated how many hours and how many units of airplanes came out of the lines. And on the first year, it took 141,000 hours basically to make one piece of airplane, one unit, right? The next year, it went down to 45,000. So already it's a more than a 2x reduction in man hours per unit of output. And then over the years, because they kept making that model over the years, it went down to 15,000, 15,000 man hours per unit of output per airplane, right? Which is nearly a 10 times reduction from the year when it was introduced. And that's really quite mind-boggling, right? That is really amazing. Whoa, the amount of labor went down like 9x. Amazing, right? And when a lot of this data came out, some people started to make calculations and everything. And then one of the consulting firms, BCG, the Boston Consulting Group, who was kind of trying to compete with McKinsey, still is competing with McKinsey, but they've always tried to make things sound a bit more scientific, more structured, more predictable, right? So they jumped on that and they say, well, okay, this is the experience curve, right? For productions that keep happening in a stable context, etc., etc. There's an experience curve, and the shape of the experience curve will basically dictate how your cost will go down, how fast your cost will go down as you gain experience making a certain type of product, right? And it's not just making products; it's any kind of routine activity. It could be service provision. It could be a lot of different types of activities. But in the starting around the end of the 60s and in the 70s, they really pushed that concept, and a lot of companies started to measure the experience curve, and they started to estimate the experience curve in such and such and such industries, right? And they're different, obviously, right? So the idea is that when you have a manufacturing plant that keeps making the same product over the months and over the years, they gain experience. And since they gain experience, they use that experience, they get more efficient in making the same output. Actually, probably a better output also, but that's another topic. And it's very true, for example, in the semiconductor industry, where within the same model, where they put in place all the manufacturing process to make a certain chip, they start and they have relatively poor yield, meaning a lot of defects, right? A lot of defective chips. And then they keep improving the process to the point where they have fewer and fewer defectives, right? And that really means much lower costs. That's one example. And the life cycle of a certain chip is not very long. Now, I should say that it depends, okay? But the cutting edge ones by TSMC or Samsung or Intel, some of them have a relatively short life. However, they are made in the many, many millions, right? And then, in addition to that, from one generation to the next, they can cram more calculation capacity, right? There's been the Moore law, right? Moore's law, basically doubling the calculation capacity every 18 months, something like that, right? And so that's the key idea here, right? You do the same thing over and over again, you get better at it, and you become more efficient at it. Kind of sounds, again, rather intuitive, right? So, and I just add one more thing on this topic is that it seems like it's more true in highly complex productions versus relatively simple productions, simply because there's more to figure out, right? And that makes sense. And also, it's more true when the situation is relatively stable, right? Where it's going to be made in the same manufacturing plant, the same model, the same configurations, and you just keep going and keep going and keep going. Because if you keep adjusting to various demands and everything, then you don't have much time to reflect over the experience you're gaining. You're always just adjusting to the demand. You you can spend a lot of time focusing internally, maybe on keeping things stable, and then really improving the production process. Does that make sense?
It does. It does. Yes, absolutely.
Mm-hmm.
I want to pick up on, if I can interject at the moment, I want to pick up on one of the examples, or the example you brought up first thing with the B-17. And this is all about a reduction of hours in order to produce exactly the same product. Now, when we mention the sort of the cost reduction over time in mass production, a lot of people automatically think of a cost reduction with respect to the supply chain. Okay. And yes, in some cases, in most cases, that is true when we're talking about a higher economy of scale with respect to increase the number of products being produced over a period of time. In other words, you can get a discount on bulk purchase. That's a true aspect. But that's not what we're really focused on today. So we need to really focus on why does the cost of production reduce over the period of time? And that is, I think you picked up on that. It's exactly where we're focused on this conversation,
Right.
Renaud. And that is
Yeah,
all
exactly.
about the experience, or another way of putting that is the learning curve. Now, yeah, a lot of people come into this and go, I've got a fairly complex product, and I think you nailed it when you said it's a complex product will benefit more than a simple product over time, because there's less to learn and there's less to fine tune from a production point of view, from a hands-on point of view. Whereas the more complex product, it does take that time for even the skilled worker to be able to manipulate the tools to the most effective process, and that does take time. And as time goes on, they can become more efficient, and the cost of labor unit comes down because they're being produced quicker because it's more efficient.
Mhm. Right. And that's different from economies of scale, right? So economies of
It is.
scale, that's it's a very popular concept that I mean, it does exist, of course. If you make products in batches of 100,000, you can keep the unit cost lower than if you make batches of 1,000 pieces. Okay. That is also true up to a certain quantity. Then from a batch of 100,000 to a batch of 1,000,000, I'm not sure you gain much. And actually at one point it becomes so hard maybe to gather all the workforce and to find some suppliers that can make, such large quantities and everything. Actually, you have maybe these economies of scale or whatever. it's called, but the maybe your unit cost might actually go up as you keep trying to increase capacity, to increase the batch size, let's say, right? So we're not talking about the batch size, like the number of pieces made at the same time. We're talking about cumulatively over time, right? You have a production that starts, maybe there's a pre-production pilot run, maybe 100 pieces, then another one of 100 pieces, and then increasing the rate, maybe 500 pieces, whatever, 1,200 pieces, 3,000 pieces, 5,000 pieces, 10,000 pieces. Well, cumulatively, when you get to that 10,000 pieces, actually, cumulatively, you might have made whatever, 16,000 pieces, right? Well, that is the key number that's important here. It's all about the cumulative experience over time, and really in relatively short time. I mean, if possible, continuous production, right? Just like you would have the assembly of airplanes, they don't just like stop and then hurry up to make 50 planes and then stop for a couple of months and then hurry up again. The level, the amount of units that they produce, so there's more or less constant production, right? The, this is where you can be much more efficient. You really have dedicated resources, and you really have people who keep working on improvement projects. Because if you stop for 2 months, people get to something else, then they come back. First, they need to remember everything, right, and get back into the pace. So it's about the cumulative number, and it's about as continuous a production process as possible. These really have a big impact.
It does. And also, I want to touch on the fact that it goes beyond the workforce. We've been focused on the production line, let's say, and sort of assembling products, but it goes beyond that. As an organization, it is really focused on not just the individual getting better. Clearly that does help, but it's also about improving the tools that are used in order to put something together over a period of time. You become, we need sort of a specialized tool for this because it will improve the speed, the agility, the efficiency of putting things together. And that leads on to the next thing, which is procedures. Standard working procedures get better over a period of time. The more you do something, the more you understand what is happening with different components going together, assembly sequences, processes, and those, processes within the organization get better as well. And all of this has a cumulative effect with respect to minimizing wasted time and potentially wasted movement within sort of the process of putting something together, whether that be a cell phone or an airplane. Regardless of the size, it does get better with time. And that minimizing waste of time and motion does accumulate into this cost reduction. So that's all added to that as well.
Right. And that brings us to the point that it does take engineering resources and it does take management attention to drive these improvements. Because if you have a bunch of people and you tell them, okay, we'll pay you by the hour, and like there's zero recording any kind of indicator, performance indicator, and you just keep going, well, then you can have some perverse effects here where people say, well, we're very happy making whatever, 2 airplanes a week, delivering 2 airplanes a week, and that's it. And then if they try to push us, we'll just push back because this is kind of a comfortable job, right? And there is some of that. And then you have all kinds of of tricks. I mean, if you go into some kind of adversarial management / employee relationships, it's bad, and then you have the foreman who comes and accelerates the speed of the conveyor belt a little bit, and then you have the guys from the union who come and check it up and measure it.
Yeah.
And then you have people actually trying to pace themselves and to say, well, I should not go faster than that because otherwise the other guys around me, they will hate me because then everybody has to go faster. And then once we raise the bar, then management will say, okay, you guys can do it, so you have to do it every day. You know, and there's actually a lot of factories where that's true, and that's really bad. And
That's right.
there's
Yeah.
not,
And there's a negative effect to that. Exactly what you said there. If sort of things speed up to the point where you're just trying to keep up with the production line in order to meet your required output per person, then that's where quality issues start to creep in, which is obviously having a negative effect on the overall cost of the product. So that is going against the whole idea of reducing cost over a period of time, because you are producing more waste because it's being rushed unnecessarily. This is believe it or not, this is and I think you mentioned it when we were talking sort of before we started the podcast. Really, this is a complex subject, and it's a very deep subject that really needs to be taken on as a complete company from top to bottom. It's not just about forcing the labor on the production line to go faster or produce more products or whatever. This covers the whole process from start to finish. It covers the efficiency of purchasing. It covers the quality aspects. It covers, material quality coming in versus going out. It covers every aspect of the business, really.
yeah, you're right. So that's why, as I mentioned, it it takes a lot of engineering work, and it takes also a lot of management attention and good management, right? Because you can really ruin everything with bad management.
Yeah.
But you need to push for improvements, but then you need to have the engineering muscle to make it happen. Okay, so spend 10% of the hours doing rework. Well, what are the top sources of quality issues that we need to rework? Okay, let's fix them one by one, and let's make sure they don't recur. And and then okay, what's slowing us down? What's what could be faster? Okay, then we need to have a plan. Maybe, oh, if we had some better tooling here, a fixture here to keep it nicely in place, then the
Yeah.
person will not fumble. Okay, will be faster. And then next step is, well, now that we have this nice fixture, that the person puts the part in it and then he holds it nicely and he aligns the other parts. Boom. Then can we improve it? This is semi-automation. And then over time, can we go in direction of higher, more high-tech automation, right? Over time. But that also takes investment. You're investing in engineering time. You're also investing in more automated equipment. Sometimes the return on investment is 2 or 3 years or longer, right? Sometimes it allows you to on save some electricity, save some material. Or in that case, sometimes the return on investment is like 4 or 5 years, and it's okay because it's also a way to go green a little bit, right? You hit two birds at the same time. So there's quality engineering work. There's process engineering, industrial engineering, etc. kind of work. There's working with specialized vendors to develop specialized equipment to do certain operations that are maybe a bit unique, and it's going to be just for you maybe. Well, that takes a lot of work, right? And of course, working with the suppliers, now that's another ballgame. The suppliers themselves should also experience the experience curve. They should benefit, from the experience curve, but maybe they need to have a bit of a notch. They need to be pushed. They need to invest the engineering, the engineering work and the management attention, right? And maybe they need help. Maybe as the larger organization, you work with smaller companies that don't really know how to do these things. But maybe you need to have your supplier quality engineers, and you need to have your supplier productivity engineers, or whatever you call them, to go there and show the suppliers what they should do, basically, right? So it takes, it doesn't happen on its own in a vacuum, right? There's a lot of things that need to come together nicely to really reap the benefits out of this experience effect.
Very true. Very true. One of the things you picked up on there, I just want to give my spin on that, is sort of engineering costs. And a lot of that is really investing in the non-reoccurring engineering, like you talked about, like
Mm,
jigs, fixtures, and sort of some of the automotive equipment. They would be obviously part of the cost of production, or part of the cost analysis of the actual product itself, but they're a one-off cost, potentially a one-off cost, and they would be sort of spread out over a number of months or years, or even component quantities. So that is really when we look at the cost of a startup product versus a 1 year old mature product, or even a 3 to 4 or 5 year old mature product. The initial startup of the individual component cost is going to be higher, simply because you've got all of these non-reoccurring engineering costs, all of the other associated costs with starting up on a product, including the inefficiencies of the whole process, which we've been talking about. Once everything is cleared up and all of the jigs and fixtures are in place, all of the automated assembly or inspection equipment's all in place and it's done, this is where you're really going to see the benefits of cost reduction over a period of
mm,
time.
right. And conversely, when you're starting with a pilot run, it's the first time you're going to be producing that specific product, and there's nothing really quite like it. It's really a new product. Well, for that factory anyway. Well, it's not going to be cheap. It's going to be much more expensive to make the first 100 pieces than to make, let's say, the second or third batch after that, right? The per
Yeah,
per
very
per,
true.
per unit. The per unit cost is much more expensive. Actually, at one point we were discussing maybe we should charge 3 times the price when we make just 50 pieces or 100 pieces at the beginning. And then we were thinking, well, probably better to just charge for the setup cost and all these kind of things, and some extra for the time spent. I was going to say time wasted because of inefficiency. No, the time spent to actually learn all the kinks and troubleshoot the issues and fix the issues on the fly, and just have a lot more supervisory attention and engineering attention on preparing for the pilot run, but and also attending to the pilot run as it happens, right? Not just for assembly, but also every custom custom design component that has to be manufactured. Whereas chances are, yeah, it's manufactured for the first time. Same thing, much higher risk, needs to be followed up very carefully, right? So all of that is extra cost. Now, on the other hand, we don't want our customers to say, well, no, we don't want to do a pilot run, whatever, it's too expensive. Well, wait a minute, whether it's a separate pilot run of 50 pieces or 100 pieces, something, or you go straight into a batch of whatever, 2,000 pieces, the first 100 pieces will be painful anyway and would be expensive anyway, right? So it's much better to release less material to the line. I think that's really a key concept here. Don't put too much material at risk. You're gonna have a lot of defectives. You're gonna spend a lot of man hours making these products, and that's fine because it's in a separate environment. It's still a new product introduction, right? There's more supervisory attention, and it's fine, right? But when you say, okay, let's go into making thousands of pieces, well, it should be actually ready. The whole process, the manufacturing process, the testing process, at the assembly level, at the component level, everything should be ready for it, right? If you haven't even made 50 finished completed units, how can you tell you're even ready to make 1,000 pieces in a batch? I mean, come on. If it's a new product, a little bit complex or very complex, you don't know, and you're really rolling the dice, right? So that's at the very start of production is tricky, and it does consume a lot more resources.
That's a very true statement, and it really comes down to looking, excuse me, looking at the pilot run. You can't really work out what the cost of a product is during the pilot run. That pilot run which you talked about is really down to making sure that everything's in place before you actually do start to release more materials onto the production line. So it's in my opinion, it is super, super important to have a pilot run on any new product. But that's just part of the learning curve, let's say, of getting a new product into production. That's the very start of the whole process itself.
Yeah,
It's very
absolutely.
important. Now,
Yeah.
I just want to pick up on something that I said then. It was as a learning curve. Now, a lot of people talk to us, Renaud, when we're talking about a fairly complex product with respect to, you got a steep learning curve with that product there, guys, versus a shallow learning curve. Now, what do we mean by the two? Well, it's really a case of not so much the learning curve itself. You can imagine a chart where you've got the learning on the vertical axis and the experience on the horizontal axis. With respect to what we were going back to where we started, building the B-17 bombers. The learning curve for everybody on a brand new aircraft is, there's a lot to learn, but over a period of time, everybody's learned that. But on a more complex product, you don't really want to rush the amount of learning in a short period of time. In other words, you've got a steep curve when it comes to learning. In other words, that's where the steep learning curve come from. It's better in some cases to actually take your time and learn everything systematically and get it right. Yeah, this is a fine balance with respect to, sort of what are we talking about? But a lot of people come up with like, you got a steep learning curve, versus, well, we're taking our time, we're learning everything because we want to make sure that everything is correct and right at the end of the day.
Mm. Yeah. Yeah, exactly. Exactly. So yeah, good, good to always re-emphasize that because it's
Yeah.
not only people who develop a new product don't really have that concept in mind often, but also and much worse. They talk to a lot of manufacturers who tell them, "Oh, it's fine, no problem. Get a final prototype and then go right into production. You're in a hurry, right? Yeah, yeah, yeah. Yeah, all right, that's the way to do it, no problem." And then you go into all kinds of problems. And when we do a little bit of a root cause analysis, it's like, well, you did not really follow any NPI process. You went just straight into mass production, like in an unstructured way. Okay, well, good, good luck. So, and I want to zoom out a little bit. Now, talk about the experience curve. We talk about, okay, a factory that keeps making the same product more or less, ideally in a continuous manner, in a relatively stable context, especially if the product is relatively complex, will tend to get more efficient over time. Well, is it, how does that, how does that translate in commercial terms, right? In consumer electronics, where a certain model will have maybe 12 months, maybe 18 months of useful lifetime, and then will be replaced by the next model and the next model. Is that very strong? Well, I'm sure that when Apple negotiates with Foxconn and Wistron and Pegatron and so on, they have something in place about that because at these volumes, it's so much money, right? But below that, it's not actually that common. Again, when the models will rotate, will turn over very fast. Now, you look at some other industries. For example, years ago, I was working with a big customer that was doing electrical home appliances, and their models were using some PCBA boards, and the the lifetime of a model was maybe 4 or 5 years, right? In some cases even longer. Well, they did have the requirement that the price would drop like 5% a year, at least, and they would push the suppliers, and they would actually get to the point where they had really, really bad supplier relationships because of that, because the purchasers were like requesting these price breaks without linking them to any kind of improvement plan. It was like, we don't care, that's your problem, you'll just find the ways and you'll just give us back the money, right? And it was bad because they did not understand the operations of the PCBA manufacturer. They did not understand how the PCBA manufacturer might cut costs. And then to the PCB manufacturers, like, well, we buy the electronic components at the same price, and some of them are going up, and we buy the boards, and it's pretty much, the price is not going down. And then internally, it's always the same process. It goes through SMT and reflow oven, and then we inspect like that, and blah blah blah. How you want us to cut the cost that much, right? And it was just a very adversarial relationship where, of course, when you get to that point, well, the supplier is not going to be open, is not going to tell you what they are doing in their operations. They don't really want you to come in and see their operations.
Yeah, yeah.
So actually then you don't know, and then you cannot point them in the right direction. And the purchasers what they were doing is they were looking for all kinds of excuses or reasons to say, well, right here you can save 2% because of that. So, right here, this is a big expense, and you just found a way to fix it. Well, there's that much saving. How much? Right here already. You already saved that much. Okay, boom, give it to us. What the supplier would say, okay, we relocate it to and then we use less space in the workshop, and then they would come and measure, and I would say, well, then you save that much rent because we see it's smaller. Thank you very much. You give it back to us, right?
Yeah.
And it's not just them. Some like General Motors and a lot of companies have been doing that. But when you do that, of course, your suppliers then tend to be less open over time. It's a very transactional relationship, and you're not gonna know much about what they really do. They will do it behind your back, or maybe they will not do anything. And I was like, no, look, it's exactly the same as last year. Where do you see the savings, right? And that's not what you want. You don't want that. So now there's some places where it's done the right way, right? If you look at a automotive plant, usually the general manager of the plant doesn't have control over purchasing, okay? But they have control over what happens in the plant, right? And they have cost reduction plans, maybe 5-6% a year, right? They have a target for a given model. So you have a new model, and then the model is going to be running whatever for 4 years. Well, every year the cost of labor and consumables and things like that has to go down, right? So and like scrap and rework and all these nice things. Well, okay, but a smart plant manager will think about it and will invest. Okay, I don't want too much downtime and quality issues due to poor maintenance. So I'm going to hire more maintenance people to do more preventive work. And I'm going to look at the processes, and I'm going to think of what to semi-automate and what to automate. And I'm going to think of new ways to do this and that. And I'm going to challenge the paint supplier because we have too many, I don't know, some sagging paint and different kinds of defects that we should not have. So I'm going to engage them, and I'm going to find a way with them to fix the problem, and so on and so on and so. And when it's done the right way, you really have engaged people using their brains to get to the final result of, better quality and lower costs all together. And that's what you want, right? But you get to do it in the right context. And you can't, if you do it in the wrong context, can be counterproductive. Your suppliers you're going to war with your suppliers, and that's not really what you want, I guess, right?
Absolutely. And I think that reinforces exactly what we've been saying earlier with respect to this is not just about one aspect of production. This covers, including very smart management. It includes, carefully managing your supply chain, all of the components coming into the factory. It covers all aspects. Now, if a business and a company is working like we've been talking about, and they've got all aspects of the business being carefully managed, and we've got continuous improvement as a key function throughout the whole business, then over a period of time, you're going to have a successful sort of business. You're going to have a successful company that is able to produce cost reductions year in, year out. But it takes work and it takes hard work, and it takes clever people to run that business like that. And
Exactly.
it's not just one factor. This goes very deep and way beyond just looking at the cost of a product.
Mm-hmm. Yeah, true. Well, that's a good conclusion. Thanks, Paul.
Oh, good. Yeah.
I think we can wrap it up, and I hope that we clarified what it means to cumulatively produce a lot of the same product and drive cost reduction that way. All right. Well, thanks for the listeners. I hope this was helpful. Leave us a 5-star review for the podcast if you get a chance. It's always something we appreciate. And in the meantime, we'll talk to you next week.
Talk soon. Bye-bye.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.